Let's have a look at problem 978, longest turbulent subarray. For this problem, we're going to share a dynamic programming solution. So first, I'll look through the statement of the problem, and then we'll look at the method and the procedure. Finally, we share the code and test the cases. First, let's look at the statement of the problem. So given an integer array called array, so we are required to return the length of a maximum size turbulent subarray. So the next sentence defines what's a turbulent subarray. A subarray is turbulent if the comparison sign flips between each adjacent pair of elements in the subarray. And below is a formal mathematical definition. So in short, it says that the numbers changes between increasing and decreasing as the index increases. So let's look at the examples here. So example 1 is a special case which returns length 1, and example 2 which forms a pure monotone increasing sequence. So the return is 2. We can choose 2 of the continuous elements as the subarray. And in example 1, the return is 5. The corresponding one of the corresponding longest subarray that is turbulent is 4, 2, 10, 7, 8. So we cannot extend this subarray any longer, either from right or from left. From right, we have 8. 8 equals 8. But for a turbulent array, 2 adjacent numbers cannot be equal. We can also not extend to the left, because if we extend to the left, we have 9, 4, 2. So these 3 numbers is monotone decreasing. So we can only include 4, 2. So that's the example 1. So let's look at the constraints of the problem. The constraint 1 basically says that the array is not empty and its length is bounded above by 4 times 10 to the power 4. And the latter says that we cannot treat this problem purely by brute force. And the second constraint is about range of element in the array, which is not negative. So with that said, let's look at the method and the procedure. So the method we're going to provide here is a dynamic programming method. So for using a standard dynamic programming here, so we use a DP table. So as we initialize the DP in such a format, so it's crucial to understand what's the meaning of the generic element in the DP table. That is the meaning of DPI. So here we define DPI is the length of longest turbulent subarray that ends exactly at index I. So in other words, with this interpretation, the return should be the maximum of DP by interpreting its meaning. So with that said, let's look at one example. So actually we write the update rule here specifically for convenience of check. So in example 1, so we have an array and we have so this is the initialization of our DP table. So consider a single element number, so it's a turbulent subarray of length 1. And in the second one, we compare the first element and the second element, see if they are equal or not. If not, at the first index, we can have a subarray that is turbulent and has length 2. So this is the initialization. Now let's examine the final state. Actually, this problem, if just by our intuition, we can easily spot the longest subarray. So ending at index 2, so we have 9, 4, 2. We can only have 4 and 2. So we have 2 here. At index 3, we have 10. So we have 4, 2, 10. So this has length 3. Ending at index 4, we have 4, 2, 10, 7. So we have length 4. Ending at index 5, we have 4, 2, 10, 7, 8, which has length 5. ending at index 6, so we have 8, but 8 equals the previous one, it's also 8, so the turbulent subarray ending at this index has length 1, because we can only include one 8. Ending at index 7, we have 1, we have 8, 1, so the length is 2. We cannot include the previous 8, because 8 and 8 are equal. So ending at index 8, we have none, but in this case we have 8, 1, none, and the length is 3. So overall, we are going to return the maximal of this DP table, that final state, that is 5. So let's explain the intuition here in the update rule or recursion relation. So we only need to consider the index I greater or equal than 2. In other words, we're starting from the third element in the DP table. So the first clause is that if array I equals its previous one. So in this case, the longest turbulent subarray ending at index I is 1. We cannot include the previous one. Item B considers the case array I does not equal its previous one. So in this case, we need to check if the previous one and its previous element in the array are equal or not. If they are equal, basically we need to set the current index for DP equals 2, which corresponding to the case 8, 8, 1 or 8, 8, say 10. So in this case, ending at 1, we have length 2. Ending at 10, we have length 2 turbulent subarray. So the item B2 is that when array I-1 does not equals array I-2. So which means that we need to check the turbulent condition in this case. So the turbulent condition can be encoded like this formula. So basically the increment from I-1 to I and the increment from I-2 to I-1 are of different sign. So in this case, which says that we can extend the longest turbulent subarray ending at index 1 to index 2. So that this extension makes that dpi equals dp I-1 plus 1. Otherwise, these three numbers are monotone, either like this, none, 4, 2, or 2, 4, none. So in this case, the longest turbulent subarray ending at the current index is 2, like 4, 2, or 4, none. So that's about the update rule or recursion relation. So with this finished, let's look at the code. So first, I will treat the edge case. The edge case is that when the length is 1, so we just need to return 1. So for this, let me first track the length information of array, and then if length equals 1, so we just return 1. So secondly, we do the initialization. So later we will compare the result with this example. So for the initialization, we first initialize dp by all ones. Then for the first index, the index 1, which corresponds to the second element in dp, we compare if array 1 equals array 0. So if equal, so we can only have, we do not need to do anything. If not equal, so we have dp1 equals 2. So that's the initialization. So now we are ready to do the update. So the recursion step. So for this step, we are going to start from index 2 as specified by the rule above. Then the first thing we want to check is if array I and array I-1 is equal or not. If it's equal, we just keep it as of now. If they're not equal, we are going to do the real work. If array I does not equals array I-1. So in this case, we are going to check if array I-1 equals their previous one. So if it's equal, so in this case, we are going to set dpi equals 2. So which corresponds to the case like 8, H2 or H say 10. So this is one case. In other case, if they are not equal, so we need to check the turbulent condition. So we want to check if array I minus array I minus 1 times array I minus 1 minus array I minus 2 satisfies the turbulent condition. So if so, we're going to set dpi equals dp I minus 1 plus 1, extend the length by 1. So notice that here I minus 2 is okay because we are starting from 2. So I minus 2 is greater or equal than 0. So otherwise, it forms a monotone sequence of these three numbers. We're going to set dpi equals 2. So this corresponding to the case like none, 4, 2 or 2, 4, none as specified above. So with that said, we are ready to do the return. So we return the maximal of the dp. So return maximal of dp. So actually, if we initialize an additional variable, then each time we update the variable, we can directly return the maximum length. But for here, this should be fine. So let's check the special cases. So this passes the first one. So now let me print out the dp initialization and the final state to compare with the above explanation. So here, let me print f init state of this dp table, and also we print here f, so the final state of the dp table. So let's compare with the example explained above. So this is the initialization here, corresponding to this one, and this is the final state. So here we explained using our intuition, and this is following the update rule. So they match each other. So now with that said, let's check the generic case. Yeah, it passes the generic case. So I guess for this problem, so that's about it. So this problem actually can be solved using two-pointer or other method, but we feel that this dp method is a direct and intuitive method, so we present here, and hopefully it's of use. Thank you very much.